Wave-particle duality. Light can be shown to have particle effects. The photoelectric effect can only be explained in terms of light being particles or photons. Electrons sometimes show wave effects, for example through the electron diffraction experiments. Waves and particles are models that help us to explain certain observations. Light and electrons are said to display wave-particle duality, with some of their features being best described as a wave, some best described as particles. They can often seem to travel as waves and arrive as lumps or particles. Now to look at a couple of examples. Here Young's two-slit experiment is being done with light. A coherent light source, in this case a laser, shone onto two slits. The light as a wave travels out from the slits, and where the two waves meet here we get constructive and destructive interference. We'll look more at what we find in a minute. This is the same experiment but now done with electrons, where an electron gun is firing electrons which will either pass through this slit or this slit, travel towards the screen and interfere at this point here. In both the cases of light and electrons, this is what we would see on the screen, a series of dark and light fringes. I can show this with a wave here, where here there is a high amplitude showing a bright region. Here we're at the center of zero displacement, showing a dark region. Here a large negative amplitude and another bright region. The square of the amplitude, or the amplitude squared, this being the amplitude, is shown to be proportional to the wave energy per square meter per second, or the wave power at a particular point. If I add the square of the amplitude on top of the screen diagram here, we see a low amplitude squared in a dark region, a high amplitude squared in a light region. By squaring you'll see that this region of negative amplitude becomes positive. This squared amplitude must be linked to the number of photons or electrons arriving at a point every second, or the power at that point. So the square of the amplitude gives the probability of a photon or electron arriving at that point. Here we have a large amplitude squared and a high probability, a bright region, zero amplitude squared, leading to zero probability, a dark region. So both the light, which had previously been considered as a wave, and the electrons, which had previously been considered as particles, seem to be interfering, which is best described as a wave model. And yet their arrival, as shown by the photoelectric effect, has to be explained in terms of them being particles. They display wave-particle duality.